All right, you came back again. Great job. So now we want to talk about an application of calculus. So why do scientists use calculus in the first place? So here's an application of calculus. In physics, you will learn that the speed v of an object depends on its original speed, v sub 0, and its acceleration a, and then all of those letters are combined into this formula. So the final speed of an object, could be a car, is going to be equal to what was its original speed, and then it also depends on, was the car accelerating, and then it also depends on how much time has elapsed. So if you don't understand that formula, don't worry about it, but in physics, this is a formula that we're going to look at. So this is the formula that will tell you the speed of an object if you know its original speed, if you know if it's accelerating, and then also how much time has elapsed. So the question is going to be, what is the significance of the derivative of it? So we're going to take the derivative of the velocity with respect to time. See, the variable is t. So this is called the independent variable, and then this one over here is the dependent variable, because this one depends on what the t is. So we're going to take the derivative of v with respect to t, okay, and so that would be the derivative of this thing with respect to t plus the derivative with respect to t of this thing. So it's kind of like in algebra that you can distribute the derivative. So the derivative will act on this plus it will act on this one over here. Now this is a constant. So what happens when something is constant and it changes? Well, it's going to be a 0. So the change in something that is constant is going to be 0. So this part right here is going to be a big fat 0. And then over here, this a, you can pull it out in front, and so this is a is equal to the derivative of t with respect to t, but what do you think happens? That cancels out. So what are you left with? The derivative of velocity with respect to time is the acceleration of the object. So that's the definition of acceleration. It's the change in speed of an object with time. So that's an application of calculus. Well, what about an integral? So let's go to the next part here. So what is the significance of doing the integral of it? So this was the derivative of this one. So let's do the integral of it. So this time we're going to go the integral of v and then dt is going to be equal to the integral. Okay, now let's substitute in. So we need to find the integral of v sub 0 plus a t, and then this whole thing is being multiplied by dt. Now, in the same way that we distributed the derivative over these two pieces, we can distribute the dt thing. So we're going to say that this is two integrals. So you got v sub 0 dt plus, and then we're going to do this one over here. This one's the integral of a t dt. Okay, so let's do this first one. Well, this is a constant, so we can pull that constant out in front, and then when we do the integral, that's just t. So the first part there is v sub 0 times t. Okay, what about this one over here? Now this one's more complicated, so we're going to have to do the integral of this t thing, and then that turns out to be 1/2 AT squared. So go back to that chart and you can see that that's what the integral of that one would be. Plus a constant. So there's always a constant whenever you do an integral. So what is the significance of that constant? So to find out what the constant C is, you're going to go back to this formula. Okay, R equals V sub 0 times T, 1/2 AT squared plus C. Plug in T equals 0. So what is V sub 0 times 0? 0. What is 0 squared? 0. What's 0 times A? 0. What's 0 times 1/2? 0. So we got a whole bunch of zeros here. So we're going to end up with R sub 0 is equal to C. And so now take that and put it into the original formula, and you finally get this formula that says R is equal to R sub 0 plus V sub 0 times T plus 1/2 AT squared. And so the significance is R is the distance an object travels, and that depends on what was its starting point, that's the R sub 0, and then it also depends on how fast was it going, so that's the V sub 0, and it also depends on whether it was accelerating, that's the A. So there is an example of how you would use calculus in a physics class. Now, you're not going to do it, so don't worry about this. I'm just showing you that maybe calculus is not so scary. Well, maybe it now is scary to you. I don't know. But anyway, that's an introduction to calculus. All right, so let's take a break, and when we come back, I'm going to show you how to use a Microsoft Excel spreadsheet.